Hi, it's Wendy, and this is part 5 of the video series on doing file I/O, or input and output, in Java. So in the first part of this series, we just did an overview of file I/O in Java, and we looked at file structure and a lot of different terminology. And then in the second part, we just did a quick look at the file I/O API. Then we did some file output code, and then we did some file input code. And in this part, what I'm going to do is actually just demonstrate a bunch of different things, and that'll show you some of the applications that you can write using file I/O and all the other stuff that we've learned so far. So I'm going to do 3 demonstrations in this video. The first one, and this will be a really quick one, I'm just going to show you how you can do file output using a GUI application. In our previous videos, we did it all in the console. So we're going to do that with the GUI. And then we're going to do the same thing with file input. Again, it's going to be really quick. I'm going to post a lot of the code for these 2 examples in case you want to try them yourself after watching the video. And then the third demo I'm going to do is a little more comprehensive. It's going to include file input and output in the same application, and this is actually going to make use of things like array lists. So for these demonstrations, we're going to be using this class called the tip class that I've already created. Again, I'll make this available to you so you can try this out yourself. And it models a tip that someone receives. So you might be, for example, an Uber driver or an Instacart delivery person, and you want to keep track of the tips that you make so that you can later report them on your income taxes. And so I created a class called tip. Now, I saved the date and time as a string. You wouldn't normally do this. You would probably use local date or local date time even. But I didn't want to get into teaching you how to do that now because it's not really time for that. But I do have a version of this class that does use the local date time object instead. So I'll try to make note of that and make that available in case you want to learn more about how to properly work with dates and times. I decided to use a string for this version just because it's a little easier for now. In the long run, it's not, but for now it's easier. And so I've got a default constructor, I've got a 3-parameter constructor, the get and set methods, and a toString, and it's all pretty basic. So we're going to use this class as our model in these demonstrations that we're going to be doing. Now imagine that we want to create a GUI application that allows a user to save tip information to a data file. So thinking about what that GUI might look like, I'm probably going to have label and text box pair so the user can type in the data. So I'm probably just going to use a VBox here for now because it's easier. So they might have a date field, and then we might have a time field. Again, if I'm using the local date time class, which ideally in real life, that's what you would use, there is actually a date picker that's already part of JavaFX that you would use. I might have a tutorial on this already somewhere, actually. I'll look into that. If I forget, just ask me because it's kind of cool. It's really easy to use too. And I'm going to have an amount field. And then below this, I'm going to have, again, I'm using a VBox, so I'm just going to make all this vertical. So I'm going to have 2 buttons, one to save and one to exit. And of course, my actual UI is going to be a lot neater than how I'm drawing it here. Oops, that was supposed to be a hotkey there. There. So this what might be, you might come up with a better design, that's fine. So this might be how I might design the UI. So in previous programs that we wrote where we were just doing console I/O, we would just simply ask the user to enter some data and then save it to the file. And so remember the 3 steps we have when we want to output data to the file. So the first thing we want to do is we want to connect a stream, an output stream, to the actual file itself. That's going to allow us to save the data. Then we actually write the data to the file. And lastly, something you don't want to forget is you want to close that stream. Otherwise, the data in the buffer doesn't get flushed out properly. So the question then becomes, where do I put this? So I have some different events that are going to occur in my program. The program's going to start up. The user's going to type some things. They're going to click save, and that might repeat. And then eventually they'll click exit. So in the beginning, we might have written a program that when they click save, we might do all three of these steps. Connect to the stream, write the data, close the stream. And when they type more data, they click save again, we connect to the stream, write the data, close the stream. If the user's only going to add 1 or 2 records, that's fine. But in a real life situation, in this kind of thing, if you're working as a delivery driver or whatever for a couple of hours a day, or maybe 8 hours a day, you're going to end up, entering tips and saving them repeatedly while the program is running. Maybe this is an app on your phone, for example. So it would be really inefficient to repeatedly open and close the stream constantly. So we need to find a way to say, well, when the program begins, I want to just open the stream once, and then the user can write as many times as they want. And then at the end of the program, I want to close the stream. And that's a very common way to write an application like this one. Connect to the file as soon as you start the program, and then disconnect from the file as soon as you exit the program. We can do this. So for example, step number 1, if you think about where do we usually write code that we want to execute when the GUI is starting up, so for example, populating a list view, well, we do that in the initialize method. So we can go to our initialize method and do the code for step number 1. And then step number 2, should be pretty obvious. Whenever the user clicks on save, that's where we want to actually write the data to the file or the buffer or whatever. So that one's an easy one. So that takes care of step 2. And then for step number 3, when can we guarantee there's a spot where we can write code to close the stream when the program terminates? Well, when the user clicks the exit button. So I could write code in my exit button that performs the steps needed for step number 3. So there's my 3-step process, and that's how we're going to divide it up in our application. So here I am in NetBeans. I want you to, if you haven't already, if you're going to do this with me, you don't have to. You can watch this first and then go back and do it on your own. If you're going to do it with me, start up a new project and grab the tip class and add the tip class to your project as a model. And what you'll notice is I did add a couple of extra things. I know I wasn't going to get heavily into the local date time, but I did use a few things. So as I mentioned before, ideally, my data member for the date and time would be a local date time object. Like I said before, I do have a version of this tip class that uses that. And maybe I'll link to it in here. I might remember to do that. I might not. We'll see. If I forget, just ask. So there's the 2 strings I'm going to use for this version for date and time, and there's the amount. And I did add some code with some extra comments that you wouldn't normally use that when I initialized the date and the time, I didn't want to get into trying to figure out when the current date is using something other than local date time. So in case you're curious, this grabs the current date and time, and then I just parse the date part of it into a string and the time part of it into a string. You can look up the local date time class, the date time formatter, and then it'll show you all these constants and methods and stuff if you're interested in more on that. I do have some notes on this for my Java 3 class if you want to check those out. And then I did the usual constructors. Now in the set date and set time, I didn't feel like writing the code manually to validate the date and time, like check for leap years. And you don't want to say like June 31st, for example, because that's invalid. So I used the local date class and the local time class, which are 2 other classes in the java.time package that you might be interested in. So I split up the date. I really only chose it because of this constant up here. I chose to use this format here, 4 digits for year, a dash, 2 digits for month, 2 digits for day. That's just how I chose to do it because it was easier because I was writing this really fast. So I split up the date string into its individual parts. Each part is separated by that dash symbol. And then I created a local date object, and I didn't actually use it for anything, but what this does, it takes each of the individual parts and creates a date. And if any of these cause an invalid date, it'll throw a date time exception, which is, you haven't learned this term yet, but it's an unchecked exception, which means you don't have to handle it. You can actually ignore it if you want to, and that's what we're going to do. So The other thing is not only will this throw a date time exception, but if they use a different symbol or if any of these pieces contains a non-digit, then it'll throw either index out of bounds or number format exception, which are also unchecked exceptions, which means we shouldn't really try catch those. It's not a good idea. So it might throw any of those 3 exceptions, but I'm not worried about that right now for reasons that we'll talk about in the next lesson. And I actually did the same thing for the time, but I used local time. So there's a bunch of classes in the java.time package that you might want to look at. Local time, local date time, which is date and time together, and the date formatter. So I did pretty much the same thing with the time as well, with minutes and hours and minutes. So you can look that up if you're interested. And then everything else is pretty straightforward. The toString, I just had it return the date and the time. That's because one of these demos, I was going to do a list view and I changed my mind, and that would have made things easier. But it doesn't matter. The value that comes out of the toString is kind of irrelevant for these demonstrations. So there's the tip class, in case you were curious. And then I also put a GUI up there for you. So if you want to copy this GUI, and then you can just focus on the controller code, that's fine. But it basically is a VBox. It's pretty much what I drew in the picture. That's it there. 3 text fields for date, time, and amount, a save, and an exit button. That's pretty much what I have here. And I've got the on action already set up for my save and my exit. Notice that when you're asking the user to enter an input and that input needs to be in a specific format, you should tell the user that. So you'll notice that, especially when this appears, you'll notice that I've actually told the user, this is the format I want my date and my time to actually be in. So let's get to the controller. So as we saw in the diagram, we want to do this in 3 steps, right? Just like we're supposed to. So we're going to do the first step, connecting to the file stream, in the initialize method. So let's do that. So now your first instinct might be go ahead and create our print writer. And of course, we have to nest in there a buffered writer and a file writer. And I'm going to use the data subdirectory and call it tips.txt. And don't forget to add the second argument to file writer true, because somebody might want to run this program, add some records, and then tomorrow they're going to come back and add more records. So we'll want to append. We also need to import all of these things, which we've done this before. And you'll notice it's saying, oh, this could throw an IO exception. You need to deal with that, which is expected. Now, if you thought of that ahead of time, good for you. It's okay. But it's okay if you didn't, because NetBeans will warn you. And this has to be imported as well. And I'm just going to, for now, print a stack trace. We are going to talk a little bit about some of the exception handling today, but there's actually a whole lesson on that coming up. There. So what this will do is it'll open the stream. So that's what we want to do for the first stage or first part or first step of our file output application. Now, step 2 is to write the data to the file. I'm going to skip that for a second. I want to do step 3 next because it just makes sense, because we're thinking about opening the stream and now we'll think about closing the stream, and then we'll worry about the middle bits last. So closing the stream, this is going to go in my exit button. So if you look at your FXML that I gave you, there is already an on action. It's calling exit. So we need to create that. Don't forget to tag it with the FXML, private void exit. There, and we have to import all these things. Make sure, again, you get the right stuff. Yes. So typically, we have 2 things we want to do. We want to close the stream, and then we want to actually close the stage, which you've done before in previous exercises and assignments. So here's where, and again, if you thought of this ahead of time, that's awesome, good for you. But if you didn't, that's okay. This is the thought process that some people take when they write this kind of program. So you're thinking, okay, I need to close the stream. So to close the stream, I need to take my file out and invoke the close method. So the first thing you realize, hopefully, is that right now file out is local to the initialize method. So we can't access it in our exit. But that's easy to fix. And this is pretty typical. So instead of declaring it inside, don't worry about that. Instead of declaring it inside initialize, we'll make it a data member. This makes perfect sense. Oops, why am I putting that there? We'll make it a data member. So private print writer file out, and just assign it a null just to avoid any Java warnings and messages that we don't really care about. So we'll make it a private data member, and then we will just access that in initialize, and we're going to access that in exit. So we know that we would need to say fileout.close. However, there's one other thing you need to think about. What if, when I start up my program, some kind of exception occurs when I'm connecting the stream to the data file, and it prints the stack trace? When that happens, the GUI will still appear, but then there's a stack trace in the console window. Later, we'll talk about how to get a message on the screen for the user. But what ends up happening is this file out is still null because no stream was ever created. So if an exception occurs, then file out is null and the user probably wants to exit. So they'll click the exit button. But then what's going to happen, as you can probably guess, if file out is null, invoking any method on a null object will give you a null pointer exception. We've talked about this many times in other videos. So what you should do, instead of just saying fileout.close, only invoke fileout.close if fileout is not null. So if fileout is not equal to null, then go ahead and close the stream. There you go. And then you just do your normal like stage. I have to grab the stage. I need an object to grab it from. You know, it's funny. You can actually grab it from any of these objects because they're all in the same scene. So since I am eventually going to have to access my text fields, I'm going to use those. So I'm going to go ahead and, even though we don't need them for coding yet, I am going to go ahead and create my text field variables. And what was the last one? TXT amount. Again, you can use the exit button, but you don't have to. So it might save a little memory. I'm just going to use one of these text boxes. They're all in the same scene, so this code will work for any of these controls. So I'm just going to use TXT date. You can use any of the three. Get scene.get window, and that needs to be cast into a stage because it's actually a window. And then stage.close. Yes, I'm going to import these two. This, by the way, you did this in one of the previous assignments, but this was posted in Piazza quite a while back. So there you go. So there's steps 1 and steps 3. So we connect to the file or connect to the stream to the file when the program starts. And then if everything went well and we have a stream to close, we go ahead and close it and then exit when the program ends. So the next thing is to do the in-between stuff. So the in-between stuff is going to happen when the user clicks on the save button. So private void save. And this should be really easy because you've actually done this already. In fact, you've done all of this already. We're just doing it in a different way. So this is going to save a single record to the file. So what I want you to do as an exercise, I want you to actually do 3 things. First, I want you to write the statement that writes a record to the file. So take all of the values the user entered and write it to the file. If you have time to validate the data first, great. If not, don't worry about it. I am actually going to cover that in another video. The next thing I want you to do, and it's important to give the user feedback. So when I, for example, save a record, let me go back to my picture here. When I type in some data, so let's say the user types in a date, they type in a time, that's my writing, and then they type in an amount and they click on the save button and then they're staring at the screen and they're like, did it save? I don't know. So what's the user probably going to do? They're going to think it didn't work and they're going to click save again, or they may like click, 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 click. It's not working. Click, 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 click. And what's it doing behind the scenes? Every time they click that save, it's writing that same data to the file over and over and over again. So you need to provide feedback to your user, not just when they make errors, but you need to provide feedback so they know that things are working properly. So you could, I guess, pop up a dialog or show a message, record saved successfully. And in some applications, that's okay. But in other applications like this one, they're probably gonna go and type in a new tip right away. And so to do that, what we may prefer to do instead, and this is, I love this, actually, I see this in a lot of applications, is when they click save, you just clear all 3 fields. And you don't even have to say anything, just empty the fields. And it's kind of funny, in the user's mind, they imagine that when they press save and the data in the text boxes disappears, they've imagined that it's left and gone into the file. It sounds like a silly thing, but I swear that's actually how their brain's going to work. So that is feedback that shows them that it worked, and then they're not going to click save again unless they've typed new data. And the other nice thing about that is if they do want to add a new record right away, they can just go ahead and add the record. They don't have to erase what they typed previously, which if you're using a program for 8 or 10 hours a day, that's a nice little thing to have because it saves you time. So I'm going to have you do that. There's a couple of ways you can do it. We've talked about them quite a while back, but you can look it up in the API if you're not sure. So you're going to clear the text fields. And then another thing we talked about a while back is putting the focus into one of the fields. So put the focus into the first field, which is the date field. So pause the video here, give that a try, and then come back and I'll show you my answer. So here's one version of the solution. Again, there could be several versions of the solution, and I did add some of the data validation, but some of it we're going to have to talk about in a later lesson. So what I did was I did make sure that the amount was numeric. That was a key thing. So I didn't want to be calling txtamount.getText every time I needed it because I'm going to refer to it a couple of times. So I stored it in a variable, as you should, because calling a method repeatedly to get the exact same value is inefficient, as you know. So then I check to see if it matches my regex pattern for a floating point number. And if it does, then I go ahead and parse it. And then I use that along with the date and time to construct a tip object. The reason why I'm constructing a tip object is because it does the rest of the validation. So it already, as you saw, checks to make sure the date and time are valid values. And it checks to make sure the amount is a valid value, which has to be, I think, greater than 0, I believe. So it does that validation. Now it is returning it's throwing all unchecked exceptions, which you're not really supposed to handle with a try catch block. There are exceptions to that rule, but generally we shouldn't. We're going to talk more about that in another lesson. So I'm just going to let those exceptions happen because they're generally the programmer's fault if they occur. So this constructs my tip object, and then I use the printf. And again, remember that, that needs to be, this was a printf I used for a different version of this, percent %f. I'll just leave it in its raw form. So this printf will write the date, the time, and notice I'm using the date and time from the tip object because they'll be valid, and then the amount, which this version is returning a floating point, so I had to switch that to %f in my format string. And don't forget the new line on the end, that's your record delimiter. I'm using the pipe symbol as my field delimiter, and then I'm using the new line character as my record delimiter. And then here's one way to clear the fields. The other way you could have done it is you could have gone and said something like txtdate.setText to null string. That's fine too. It's a few more extra things to type, but that's okay. Clear is a lot easier, but you can use either. Both of them are equally efficient. They're fine. Everybody knows what you're doing when you write either of those two statements. And you already remember request focus from a previous exercise. Now, in my else block, this is the else block that matches this if up here. So this was the statement that said if this if the amount matches this pattern for a floating point number. So in the else block, this is going to execute if it's not a valid floating point number. And here's where I might want to display a message to the user. So there's a couple of different ways you can do this, but you need either a place to put the error message, or you need to know how to do a dialog box, which is an optional lesson. If I remember, I will post that somewhere in case you're interested. So probably the easiest thing to do right now, because we don't have time right now to learn dialog boxes, is to just display it on the screen in a label. So if you want to go to your FXML, you can go ahead and just add a label. This is usually the way I like to do it because it's just a control on the screen. It's a lot less coding. Once you see how to do dialog boxes, if you choose to check that out, it's actually quite a bit of coding. Not like a whole lot, but it's definitely like 4 or 5 lines of code to do that. But it is very cool. I'm going to set the max width. There we go, to infinity. And that all went away. Good. So there's my label, and I'm just going to create a reference to the label because we're going to need it. So private label LBL messages. I think in your assignment 4 and 5, you did the exact same thing, if I'm not mistaken. So this is kind of nice. And so for my error message, I'll just do LBL messages and dot set text, and then something nice like amount must be a decimal value. Don't say floating point value because some users don't know what that means. They're not computer people, so try and make sure you use terms that non-computer people understand. We've talked about this before. So this will save a record. Again, we haven't dealt with what about these exceptions that might be thrown from the tip class. Again, they're what we call unchecked exceptions. We're actually not supposed to handle those with a try catch, so we'll learn about that in a later lesson. For now, you are free to ignore those. So let's give this a try. So just to review what we've done, in our initialize, we connect to the file. And then whenever the user types in data and presses save, assuming everything goes well, we save that data as a record to the file. And then when the user's finished and they want to exit, we then close the connection to the file, and that will flush out any data still left in the input buffer. Let's try it. There we go. Just make this a bit bigger. So here's my UI. Again, remember I was saying earlier, it's always a good idea to make sure that you tell the user the format if you want them to enter data in a specific format. So if I type in, for example, 2020 and then 07 for the month, and then let's say 21 for the date, that was what, a week ago, and it's say like 7:45, someone tipped me $10. Like that. And then I click on save, and notice that the field's clear. So in your mind, that data was saved to the data file. And now look, the cursor is sitting there waiting in the date field because that's logically where I, as a user, am probably going to want to start typing the next record. So let's say an hour later on the same day. So 07, I already forgot what the day was, 21. I think that's what I put before. At say like 8:15, so maybe half an hour later, someone paid me $15.25 in a tip, and I click save. Oh, looking good so far. And I'm going to do one more. 07:21, and then at, what was the last one? 8:15, so 8:29. I got $5.99 and click save. All good. So now I'm going to click on exit, and what you can do is you can go and look at your files, and there's my tips.txt, and if we look, there's the 3 records that I just added. Very nice. So that's how you would typically write an application with a GUI where it just saved data to a file and nothing else. It didn't input or anything, just output only. There's probably a few extra things that you want to add and try out. We didn't really try out the error handling on the double value. You can do that if you want. I'm more interested in writing to the file right now. So So that's our demo of a file output GUI program. Let's now try doing a file input GUI program. So what we're going to do is write a really basic application where we just have a report button, and when the user clicks that report button, we're just going to display rows of each of our records. So we'll just have a column for the date, a column for the time, and a column for the tip amount formatted. And what the heck, let's put a total at the bottom as well. We might as well, right? So this kind of program, it's a little bit simpler because really when the user clicks report, they're just going to want to spew all of the data into the text area. So what I can do is I can actually, in the report button, do the similar 3 steps for reading. So I can connect to the file using an input stream for step 1. And then step 2, I want to read and process all records. Obviously, that's going to involve some looping. Hooray! And then I can then close my stream or close my connection to the file. I can actually do all of these things in the report button, so that's nice and convenient. So let's do that. So for this demo, I created a really basic view tips FXML file. Again, I'll make this available in case you want to try it out yourself. I didn't get a chance to teach you CSS. We made that an optional part of this course because of time constraints. So I set up the font using the font elements. It's not typically how you would do that. You should do that using CSS. I keep meaning to post those notes for you in case you want to learn how to do that. I will. If I forget, just remind me. So I did a little border pane with the button in the top that does the report, and you'll see it's actually already set up to call a report method. And then in the center, I put the text area so that it would stretch. In fact, I might just want to do a max width and max height in here now that I think about it. It's not that big a deal. I don't think this is in the version I'm uploading to you. I'll try and edit that and make sure it is. There. It doesn't really matter. We're not going to resize the screen for practice or anything. And so here's a trick. I'm using the same project I used for the previous demo. So what you can do, if you have multiple UIs, and each UI, of course, has their own controller, that's fine. Just go to your project, add a new FXML, add the controller, give everything the correct name, and you can still use that in the same program. You just have to make sure that you tell your code which FXML to start with. So what you do is in your start method of your application class, these are actually the 3 demos because I was trying them out to make sure they worked. All you do is whenever I do an exercise like this with more than one UI, I just keep one of each. Parent root equals FXML loader, and I just comment and uncomment depending on which ones I want to see. I do this with assignment 5 and 6. They're actually in the same application, and I just did this when I wanted to take screenshots of each one. So you can totally do that if you want, but if you want to make a whole new project, that's totally fine. Okay, so in the FXML, I created the button where the on action is the report method. We're going to add that, and I'm just checking to see the name of my text area is txt display. So in my controller, I'm just going to start off by creating a reference to the text area. Did I set editable equals false? I'm going to have to make sure I add all these things to the version I've uploaded. I keep forgetting. Just do that. All right, hopefully the version I upload to you, I'll remember to go and add these 3 things. I'm gonna add that right now to my to-do list. Okay, so there's my txt display. So in here, text area, txt display. Oops, I forgot the word private. All right, I gotta import all these things. And I'm gonna create the event handler method, private void report, action event. There. Okay, so what I want to do is I want to connect to the file, read in and parse or process all the records, and then close the connection to the file. So remember for file input, we're using scanner with a file object. So I'm going to create my file object first. So file equals new file. I don't know why I always call the variable file. I guess if you have more than one file, you probably want to be a little more self-documenting. It's in data and it's called tips.txt. And again, you got it open right there, so you can always check if you're not sure. And if the file exists, then, and you can probably anticipate we're gonna have the same kind of issue. We want to display this error message somewhere. File doesn't exist. So if the file exists, then what I want to do is I want to go ahead and construct a scanner for this file. And again, if you didn't figure this out, you would eventually, but the scanner, when you pass it a file object, is going to throw an IO exception, specifically a file not found IO exception. So you're going to need a try block. But again, if you didn't think about that until after and then you saw the error message, that's fine. It's not a big deal. Then you would just add it later. And again, for now, I'm going to print a stack trace. You could, and this is true of the other program we just wrote as well, you could display messages in your label, and that's actually not a bad idea. But again, I'm going to cover that in another video. So I'm going to go ahead and create my scanner to the file. And of course, so many things to import. Don't forget to close and assign it a null. It's generally a good practice. So I'm going to print this report. To do that, I'm going to need some column headings. I need to calculate the tip total. In fact, I'm going to do that now. I'm going to create a tip total variable to keep track of my tip total. And I'm just going to add some column headings to my report. So txtdisplay.setText. I always use setText for the headings or the title, because if I click the report a second time, it'll always start from scratch. It won't just append a new report to the existing one if I happen to click report more than once. Now, I planned out my output ahead of time, and I showed you in a previous video, or reviewed in a previous video, how to do that. So again, I recommend doing that if you're going to do this on your own. And I'm going to put 2 blank lines at the end of that so that it looks nicer. And then our usual while loop. Again, there's nothing new here, really. We're just doing it in a different environment. So while file in.hasNextLine. So this is the loop where I'm going to process each of my records. So I'm going to read in a record. So next line, I'm going to parse it into the individual fields. So record.split. And I'm splitting it at the pipe symbol because that's what I used. And the third field is my amount. That needs to be parsed into a double because I need it in order to calculate with it. I'm going to be adding it to my total, and I want to format it. Now, sometimes you got to be careful when double the parse int. Very clever. There we go. You got to be careful because in this application, we wrote the output program and you're the only one that's touching it. So you probably are okay assuming that the data in the file is valid because you wrote some pretty good code to make sure only valid data goes into the file, or at least by the time we finish exception handling, you will have. So that's fine. We can just parse it. In a larger program where there might be many pieces of the program and many people working on it, you won't necessarily be guaranteed that the data going into the file was valid data. So that means that when you're reading the data back, you need to do error handling on it. In this one, we're not going to because it's probably okay. I mean, like I said, you were the one that wrote the output program and only you, so it's all right. But again, in a larger program, a larger application with team members, you want to be really careful, especially if it's a larger program where you might use modules of that program in other applications. You don't know where the data in another application is coming from, so you want to make sure any data coming into your program is valid. But here, it's okay. So I'm going to take that amount and I'm going to add it to my tip total. I'm going to use plus equals. I don't know why some people write this the long way. Tip total equals tip total plus amount. I mean, it's a lot more typing. Why don't you just use the Java shortcut operators? It's a lot faster. And then I'm going to do a txtdisplay.append text and I'm going to string.format. Again, I planned out my output already on the side here. So like I said, I reviewed this in another video. You learned this in semester 1. And so my first format specifier is going to be the date, which was fields 0. My second format specifier is for the time, which is fields 1. And my third one is the amount, right? So that's why I formatted it with a floating point format specifier. So this loop reads a record, adds the amount to the total, and then prints that record on the screen in the text area. And then after the loop is done, I want to display my total. So now I'm gonna append text string.format, and I'm gonna do again. I did this ahead of time, like I planned out my output before. I'm gonna add an extra blank line just so that it looks nicer, and then I think it was %, minus 16s, and then %7.2f, and then a new line at the end. And the first argument is actually for the word total, and the second one is for tip total. It's just easier than typing in total followed by like 11 spaces, or total : followed by 15 spaces. It's easier to read. There we go. So again, I create the file object. If the file exists, I connect a scanner stream to my file. I start my headings on the top of my report, and then for each record, I basically retrieve the record, parse out the fields, add the amount to the total amount, and then display that record. And after all of the records are processed, I print my tip total. Now in the else block, we have a little to-do here. This is going to be our message where the file doesn't exist. So what we can do, we could add a label, I suppose, in the bottom area of our UI, but instead, what you could do is actually just use your txt display in this case. So you can do a set text, and you could say missing tip file, for example, something like that. If you want to test this out, just take the text from your tip file and paste it somewhere so you don't lose it, and then just delete the file and then run your program to see if it works, and then you can put the file back when you're done. Make sure you copy the stuff in your file though before you delete it, otherwise that would suck. Or you could just run your output program and try it all again. All right, let's run this. Okay, I actually paused to make the font a bit bigger in the text area because it actually wasn't very clear. At least I don't think it would have ended up clear in the video. So let's see. Oh, that's much better. So there's my tip report. So I managed to get my date heading kind of centered over the date column. You didn't have to, I'm kind of anal that way. And then there's the time column and the amount column all nice and formatted, and the total lines up. Oh, awesome. So there's my report. Nice. So that's a simple example of how to do file input in a GUI. The next example I want to do with you is a little more comprehensive, and this is going to show you how to do both file input and output in the same GUI. So far, we've had a chance to look at how to write a GUI application that does file output, and we've also had a chance to see how to write a GUI application that does file input. So all that's left now is how to write a GUI application that does both file input and output. I'm going to cover that in a separate video because I think this video is long enough and I don't want to make them too long, so I'll see you in the next video.